Hi, in this video we're going to find a side length involved with an isosceles triangle and an inscribed circle here, so a circle inside this isosceles triangle. Now, an isosceles triangle just means that two of the lengths are the same, but that also means that these two base angles, as they're called, will be the same. Now, if we know that these three angles add up to 180, we can do 180 minus 56 to find the sum of the other two angles. And because these two are equal, we can divide it by 2. If we do that on a calculator, we get 62 degrees. So this angle here is 62, and so is the other one. Now, we need to form a right angle triangle if we want to use trigonometry. And we're trying to find the length of OA here. Now, there's a few circle theorems which are relevant here. Now, I know you might not have covered circle theorems yet, but there's two circle theorems which I'm going to teach you, which you can use to solve this problem. One circle theorem is that the angle between a tangent of the circle, now a tangent of the circle is just a line which touches the circle, and the radius of the circle, that angle between those two lines will be 90 degrees. You can sort of see it looks like 90, and it is, because it's the angle between a tangent and a radius of the circle. So that's 90. That's one circle theorem that would be relevant. And that's great because now we have a right angle triangle. And the other circle theorem that's relevant is that this length here from this point to this point and this length here will be equal in length. It's a bit like if I put my hands on my head like that, and my head is the circle and I've got my two hands like that, they're tangents to my head. Those two hands will be the same length, right? So this length here will be the same length as this. So the circle theorem is tangents from a point to the circle are equal in length. So that means that this length is equal to this one. And that means that this angle here is going to be exactly cut in half. So if that's 62, this is also 62 because it's isosceles. And then if we halve it, that means that this angle is going to be half of 62, which is 31 degrees. And now we've got everything we need to work out the length of this line OA. So let's just draw out that triangle separately. So we've got the 8 centimeters here, we've got the 31 degrees here, and we're trying to find the length of OA. Let's call it X, because we don't know it, we're going to call it X. Now at this point, we highlight the angle of interest, which is just the angle that we know that is not the right angle. And then we label these side lengths here with how they interact with this angle of interest. So this side here is opposite that angle, so it's called the opposite. We label it with O. And this side here is the hypotenuse because it's the longest side of the triangle. Remember, the hypotenuse is always opposite the right angle. So we put H for hypotenuse. And then we use SOHCAHTOA as our helpful mnemonic to work out which trigonometric ratio to use. So SOHCAHTOA. Now, what are we using here? We're using O and H. So that's going to be here, O and H. So it's this one. And remember, that was short for sine, S is short for sine of the angle of interest, theta, equals O over H. So the angle of interest is the theta, so that's made that theta, it's just a Greek letter. And let's substitute into this equation. So sine of the angle of interest, 31 degrees, which is equal to O, which is 8 over H, which is X. So we've got this. And then remember the nice trick, if the variables in the denominator of the fraction, you can swap the thing you're dividing by and the result of the calculation. So you can swap this and this. And we see in another video why that works. So you get X is equal to 8 over sine 31. Let's just do that on a calculator. And that is equal to 15.5. And do we want it to one decimal place? We do. Yeah, so that is the answer. That side length X, which is OA, is 15.5 centimeters. And we are done.